For each identity, they want to determine the non-permissible values and prove them. There's A, got it already set up. There's B. Erase this. We're actually going to do the proof first, and we'll do the non-permissible values after. Okay? So if you were proving this, you'd rewrite it, you'd draw your line. Take a quick look. Do you see any shortcut strategies you want to use? If the answer to that question is like, no, I don't see anything yet, then use your main strategy. Main strategy, can you change things to sine and cosine? Well, I have a cotangent. I can change that to cos theta over sine theta. Here's my main dividing line. On the bottom, I have cosecant. Can I change that? Yeah, I can change that to 1 over sine. What about the right side? It's already cosine. Don't change it. What do I have? I have a fraction divided by a fraction. What can I do with that? I can multiply by the reciprocal. So rewrite the first one, change to multiplying, flip the second one. If you're multiplying and you have two factors that are the same, they can cancel right out. And what am I left with? Just left with cos theta. Does that match? It does. All done. Okay. Now that we've done the proof, I find that sometimes when you've done the whole proof, it's easier to list the non-permissible values. Because in math, non-permissible values are values that you're not allowed to use. And up till now, we've learned a couple of things you're not allowed to do. You're not allowed to, what are some of the things you're not allowed to do? Bring you back? No. Divide by 0. Or take the square root of negative. So far, that's about all you've learned that you're not allowed to do. You've also learned technically you can't take sine inverse of numbers bigger than 1. So are we ever, no square roots here, are we ever dividing? Yes. In fact, I'm going to take out my highlighter and check all the places I'm dividing. Dividing here, I'm dividing here, I'm dividing here, dividing here. Those are all the places I'm dividing. Okay? So what do we know? We know that cosecant theta can't equal 0. If I make a list, I know this can't equal 0. I know this can't equal 0. And I know anything else? Those are the only ones. Okay? Technically, cosecant is the same as 1 over sine theta can't equal 0. Right? And the only way a fraction can't equal 0 is if your numerator can't equal 0. But we still have sine theta on the bottom, which also implies sine theta can't equal 0. How do we write this? Well, when is sine equal to 0 on your pi plate? 0, pi, 2 pi, dot, dot, dot. In other words, how do we write this as all of them? There's your non-permissible values. You have to write all the coterminal ones of 0 pi and 2 pi. So that would be k pi, where k is an integer. So for
We don't have to write in for the cosecant.
For the cosecant, you don't have to write anything, because if you changed it to this, the only place a fraction is equal to 0 is if the numerator is 0. And in this case, the numerator is never 0. Okay? You don't have to worry about cotangent because you're not dividing by cotangent. So let's look at the second one. We'll prove it first. Draw the line. I don't see any shortcuts, so I go with the main strategy. Main strategy says change everything to sine and cosine. Thank you. So I'll change my secant to 1 over cos. And then I need to get a single fraction. I have, right now, fractions inside of fractions. So I need to get a single fraction on the top. I need to get a single fraction on the bottom. Technically, the top, being 1 plus cos theta, is a single fraction. I could write it as 1 plus cos theta all over 1. The bottom, though, is fraction plus a fraction. I need a common denominator, so I have to multiply this by cos theta and cos theta. I'll leave some space. Here's my main fraction line. I can even write this as 1 plus cos theta all over 1, so I see it as a fraction. And on the bottom, if I get a common denominator of cos theta, the top will be cos theta plus 1. And if I have a fraction divided by a fraction, I can rewrite the top one. 1 plus cos theta over 1 multiplied by the reciprocal or the flip of the bottom one. The adding will group this together. The adding will group that together. The only way you can simplify is if factors are identical. Are these identical? Cos theta plus 1 and 1 plus cos theta? Yes. So, cancel those out. And what are we left with? We're left with just cos theta. Oh, I can't even see. I'm sure hopeful that was the other side. It is. So I can write my statement. Left side is equal to the right side. Scroll back down if you were still writing it. Nice. Now, we're going to figure out the non-permissible values after the fact. We're going to go through our entire proof and highlight everywhere we were dividing. Okay. I'll give you one shortcut. If you change everything to sine and cos, you don't have to worry about the secant, cosecant, cotangent ones. They will show up later automatically. Okay? So I don't really have to solve 1 plus secant theta equals 0. It will show up later on. So the only places I have dividing by 0, I know that cos of theta, that can't equal 0. And you have to be careful because you do have to check this one. I also know that cos of theta plus 1, that can't equal 0. When is cos of theta equal to 0? Question.
Can cos of theta as well do not equal -1.
You're right, because of this one here, if we simplify this, this means cos of theta can't equal -1. So now I have to write all of the answers that do that. I'm going to write them with a big squiggle bracket. We'll just start listing them. From 0 to 2 pi. Cos of theta is 0 at pi over 2 and 3 pi over 2. What about -1? That happens only at pi, right? And if I want to write all the coterminal ones,
Sorry for the interruption. Tous les élèves d'improvisation Husky, un petit rappel, you have a meeting at lunch in room 2D4. Un meeting qui va être très rapide, de 5 minutes, l'équipe de Impro Husky. Merci.
all right, these are the questions. Circle 4, 8II, 9II, and 11. That's not capital II.